Question 1. Find the value of 3,000 divided by 50. We can start off by crossing a 0 from the dividend and a 0 from the divider. So the division becomes 300 divided by 5, and that's equivalent to 300 divided by 10 times 2. And the reason for doing that is that it's easier to divide by 10 than it is to divide by 5. Now 300 divided by 10 is 30, and 30 times 2 is equal to 60. Question 2. Write 25.6174 correct to 2 decimal places. The second decimal place is the 1. Now the digit after the 1 is 7, which is 5 or more. And that means the 1 needs to get rounded up to a 2. So 25.6174 correct to 2 decimal places is 25.62. Question 3. Write 4 minus 1 over 3 as a mixed number. Four is equal to 3 plus 1. So we can rewrite the expression as 3 plus 1 minus 1/3. Now 1 minus 1/3 is 2/3, and 3 plus 2/3 is 3 2/3. Question 4. This magic square uses each of the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 once. In a magic square, each row, column and diagonal has the same sum. Complete the magic square by filling in the missing numbers. By inspection, we can observe that the complete diagonal adds up to 15. That means that all rows, columns, and the other diagonal also have to add up to 15. So here is the completed magic square. We have 6, 1, 8, 7, 5, 3, 2, 9, 4. Question 5. Find 3.5% of 400. This problem can be broken up into 2 steps. The first step, find 1% of 400. That's called the unitary method, where we find 1 of something. In this case, the value of 1%. Now 1% of 400 is equal to 4. Next, to find 3.5%, we multiply the 4 by 3.5. Now halving the 4 and doubling the 3.5 gives us the same value. So 4 times 3.5 is equivalent to 2 times 7, which equals 14. Question 6. Write 2 numbers that have a sum of 19 and a product of 48. By inspection, the 2 numbers are 3 and 16. 3 plus 16 equals 19, and 3 times 16 is equal to 48. Question 7. Which 2 players' scores differ by 2? We're looking for 2 numbers that have a difference or a gap of 2, regardless of whether they're positive or negative or a mix of both. Now we can see that Greg and Mark have a difference of 2 in their scores. Greg has a score of -3, Mark has a score of -5. Here are the 2 scores shown on a number line. So here's Greg, -3, here's Mark, -5, and the gap between the 2 represents the difference between the scores. Therefore, the answer is option B. Question 8. Increase 170 by 10%. This can be done in 2 steps. Firstly, work out 10% of 170. So 170 times 10%, or 10% times 170, is equal to 17. Next, add 17 to the original amount of 170. So 170 plus 17, we have 0 plus 7 is 7, 7 plus 1 is 8, and 1 plus 0 is 1. So 170 increased by 10% is 187. Question 9. Brian built a pool fence in his backyard. The plan shown uses a scale of 1 to 400. The distance on the plan from the back of the house to the pool fence is 40 millimeters. What is the actual distance in meters between the back of the house and the pool fence? The scale is quoted as 1 to 400 on this plan. That means every millimeter on the plan represents an actual distance of 400 millimeters, or the distance in reality. So to find the actual distance, we multiply the 40 millimeters here by the scale, which is 400, and that equals 16,000 millimeters. Now there are 1,000 millimeters in 1 meter, so dividing this value by 1,000, or crossing off the 3 zeros, that equals 16 meters. Question 10. Write a whole number whose square root is between 5 and 6. If a whole number has a square root that's between 5 and 6, that implies that the whole number must be between 25 and 36. Since the square root of 25 is 5, the square root of 36 is 6, therefore the square root of any number in between 25 and 36 must have a square root between 5 and 6. So possible answers are any integers from 26 to 35 inclusive. Question 11. Convert 52 over 20 to a mixed numeral. Give your answer in simplest form. The first thing I'm going to do is to simplify the improper fraction. Note that the numerator and the denominator are both even numbers, so we can divide those by 2. So 52 over 20 is equal to 26 over 10. And these are also even numbers which can be further divided by 2. So 26 divided by 2 is 13, 10 divided by 2 is 5. Now to convert 13 over 5 into a mixed numeral, 5 goes into 13 2 whole times, leaving a remainder of 3. So 52 over 20 as a mixed numeral in simplest form is 2 3/5. Question 12. Estimate the value of 71 over 4.1 plus 1.8, giving your answer as a whole number. (71 over 4.1 plus 1.8 is equal to 71 over 5.9. Now I'm going to round the 71 up to 72 and 5.9 up to 6. And the reason for that is that 6 divides 72 evenly. The question is asking for the answer as a whole number. And 72 divided by 6 is equal to 12. So this fraction here is approximately equal to 12 as a whole number. Question 13. The fraction triangle over 5 has a value between 6 and 7. Give one possible whole number for triangle. If triangle over 5 has a value between 6 and 7, multiplying the 6 and 7 by 5, that implies that the value of the triangle must be between 30 and 35. Since 30 over 5 is equal to 6, 35 over 5 is equal to 7, and the question is asking for a possible whole number for triangle. So possible answers are 31, 32, 33, or 34. Question 14. What is the cost of 15 calculators at $8.80 each? The solution may be split up into 2 steps. We can work out the cost of 10 calculators easily enough. So 10 times $8.80 per calculator is equal to $88. Next, to work out the cost of 5 calculators, this must be half of 88, since 5 is half of 10, so that gives us $44 for the remaining 5 calculators. So to find the cost of 15 calculators, we add 88 to 44 and we get $132. Question 15. The first 6 tiles of a border pattern are shown. Erica continues the pattern and notes the design on the 16th, 25th, 35th and 46th tiles. Which of the noted tiles is different from the other 3? We can start by numbering the tiles. So this is tile 1, tile 2, tile 3, tile 4, tile 5 and tile 6. Now this pattern repeats itself every 6 tiles. So going back to the beginning, this will be tile 7, tile 8, tile 9, tile 10, tile 11, tile 12, and so on. So have a look at the last tile. This is tile 6, but because it repeats every 6 tiles, this is also tile 12, tile 18, tile 24, tile 30, tile 36, and tile 42. So the 16th tile, if we start here from 18 and work backwards, so we've got 18, 17, 16, which is equivalent to the 4th tile. So I've written 4th tile here. The 25th tile, we can work forwards from 24. So this will be the 25th tile, and that's equivalent to the 1st tile. The 35th tile is equivalent to the 5th tile, and we can work backwards from 36. So this will be the 35th tile here. And the 46th tile is equivalent to the 4th tile. So if we look at the tiles, so the 4th tile and the 1st tile are the same shape. So this tile here, and this tile here are identical in shape or identical in pattern. Therefore, the odd one out is the 35th tile. Therefore, the correct answer is option C. Question 16. A bag contains 36 coloured pegs. Ernie chooses a peg at random from the bag. He records its colour and returns it to the bag. He does this 12 times. From his results in the table, what is the best estimate of the number of yellow pegs in the bag? This problem can be thought of as a relative frequency problem. So there were 12 trials, and we get that by adding these values, and it's also given in the question as well. Out of the 12 trials, 2 pegs drawn are yellow. So the relative frequency is 2 out of 12, which simplifies to 1 over 6. So the expected frequency, given that the bag contains 36 coloured pegs, is given by 1 over 6 times 36, which is equivalent to dividing 36 by 6, and that gives us 6 yellow pegs. So that's the estimate of the number of yellow pegs in the bag. Question 17. The colour pine green can be made by mixing green paint and white paint in the ratio 5:3. How much white paint is used to make 4 litres of pine green? The ratio of green to white paint is 5:3. So the first thing we need to work out is the value of 1 part. Now there are 8 parts in total. We get that by adding the 5 and the 3 together. And there are 4 litres of pine green paint that we want to make. So the value of 1 part is found by taking the volume of paint or the capacity of paint, which is 4 litres, and divide that by the 8 parts of the ratio. 4 divided by 8 gives us 0.5 litres. So to find the amount of white paint, we take the value of 1 part that we just found, which is 0.5, and we multiply it by the number of parts of white paint in the original ratio, which is 3. So 0.5 times 3 is equal to 1.5 litres. Therefore, the correct answer is option B. Question 18. The step graph shows the cost of telephone calls lasting different lengths of time. Julie makes 2 telephone calls, one lasting 1 minute 32 seconds and the other lasting 1 minute 5 seconds. What is the total cost of these two telephone calls? The first telephone call lasts 1 minute and 32 seconds, which is just over 90 seconds. So here's 90 seconds here. We'll go slightly past 90 seconds, and we're referencing this step here. And so projecting across, that corresponds to $4 for that particular phone call, and I've written that here. Now, the other phone call is 1 minute and 5 seconds, which is 65 seconds. So slightly more than 60 seconds, which is this step here, which corresponds to $3. So the total cost of the two telephone calls is $4 plus $3, which equals $7. Therefore, the correct answer is option B. Question 19. The measurements shown for these containers are in centimeters. The diagrams are not drawn to scale. Which container has a capacity of 1 litre? One litre is equivalent to 1,000 cubic centimetres. This is the conversion between capacity and volume. Now, all shapes shown are rectangular prisms, and the dimensions are in centimetres. So to find the volume of each prism, we multiply the dimensions. And what we're looking for is a product that equals 1,000, which is equivalent to 1,000 cubic centimetres or 1,000 millilitres. So looking at option A, 20 times 10 times 5, or 20 times 5 times 10, which makes the multiplication a little easier, since 20 times 5 is 100 and 100 times 10 is 1,000. Therefore, the correct answer is option A. Question 20. Each triangle in the snowflake is equilateral. The 48 sides on the perimeter are each 1 centimetre in length. What fraction of the snowflake is represented by the shaded triangle? To find the total number of equilateral triangles of side length 1 centimetre, we can partially complete the pattern on this snowflake. So what we're interested in is to count the number of equilateral triangles in the outer segments of the snowflake. So that's this segment here, 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 and here, and there are 6 of those. We also need to count the number of equilateral triangles in the interior of the snowflake. So that's this large equilateral triangle, which can be split up into smaller equilateral triangles, and there are 6 of those. So looking at the outer segments, and I've chosen one in particular since they're all identical, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 equilateral triangles in each outer segment. So that's 11 times 6 in these outer segments here. Now in the interior of the snowflake, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 small equilateral triangles in the larger equilateral triangle here. And there are 6 large equilateral triangles. So the number of small equilateral triangles in the interior of the snowflake is given by 9 by 6. So 11 times 6 plus 9 times 6 is equal to 66 plus 54, which equals to 120. That's the total number of the small equilateral triangles, like this shape here. So the fraction of the snowflake that's shaded is 1 over 120. Question 21. Zena uses the table of values to produce the straight line as shown in the graph. The point D, 7, n also lies on this line. Find the value of n. From the table of values, we can observe that when the x values go up by 1, the y values go up by 2. In other words, there's a relationship between x and y that includes doubling whatever the x value is. So y is equal to 2x. But what you'll also notice is that when you double the x, the y values are always 2 higher than what double the x is. So for example, double 1 is 2, but we actually want 4. Double 2 is 4, but we actually want 6. So the complete rule to get the correct y value is we double the x value, but then we need to add 2 after. So y is equal to 2 times x plus 2. Now to find the value of n, which corresponds to an x value of 7. This is a coordinate. The first number is the x coordinate. The second number is the y coordinate. So n represents a y coordinate. So to find the value of n, we substitute 7 into this rule here. So 2 times 7, which is 14, plus 2 is equal to 16. Therefore, n is equal to 16. Question 22. Which of the following will simplify to 120? Note, there may be more than one correct answer. Let's consider the 4 options. Option A has 30 divided by 1 over 4, which is equivalent to multiplying 30 by 4. And that equals 120. So option A is correct. Looking at option B, 1,000 divided by 120,000, if we cross off 3 zeros here and 3 zeros here, that's equivalent to 1 divided by 120, which is equal to 1 over 120, which is incorrect. Looking at option C, 60 times 20 is equivalent to 12 times 10 times 10, which equals to 1,200, which is incorrect. And looking at option D, 2.4 divided by 0.02, if we move the decimal point one place to the right in the dividend and the divisor, that's equivalent to 24 divided by 0.2, moving the decimal point another place to the right in the dividend and the divisor, we get 240 divided by 2, which is equal to 120. So option D is also correct. Question 23. Which of the following will simplify to 3? Note, there may be more than one correct answer. Looking at the 4 options, option A has the square root of 5 squared minus 4 squared, which is equal to the square root of 25 minus 16, which is equal to the square root of 9, which equals 3. So option A is correct. Option B is 1.5 squared, which is equivalent to 1.5 times 1.5, which equals 2.25, which is not equal to 3. So option B is incorrect. Looking at option C and applying order of operations, we have 27 minus 4 times 6. So we do the 4 times 6 first, and 4 times 6 is 24. So 27 minus 24 equals 3. So option C is correct. And 24 divided by 4 times 2 for option D, we get 24 divided by 4 is 6. Multiplying that by 2, we get 12. So option D is incorrect. Question 24. Which shapes will fit together to form a cube? Note, there may be more than one correct answer. One way to analyze this problem is to consider the number of small cubes required to make a larger cube that is formed by fitting together any 2 of these composite shapes. Let's have a look at shape Q. Now this is almost a cube. It looks like there's a small cube that is missing. So this consists of 7 smaller cubes. Shape R consists of 3 small cubes. Shape S consists of 4 small cubes. Shape T consists of 4 small cubes. And shape U consists of 5 small cubes. Looking at option A, if we fit together Q and U, you'll end up with 12 small cubes. So the shape that is formed cannot be a cube. So option A is incorrect. If we consider shape R and shape S, we have 3 small cubes here plus 4 small cubes here. That gives us 7 small cubes, not enough to form the cube that we're looking for. So option B is incorrect. If we take shape R and fit it to shape U, we'll have 3 small cubes plus 5 small cubes gives us 8 small cubes, and we have a complete cube. So option C is correct. And looking at option D, we have 4 small cubes and 4 small cubes, so it looks as if they're able to connect together. But if you look at it closely enough, shape T and shape S will not fit together to form a cube. So option D is incorrect. Question 25. Evaluate the square root of 2.4 squared plus 4.5 squared. Using your calculator, the square root of 2.4 squared plus 4.5 squared is equal to 5.1. Question 26. What is the greatest number of 45-cent stamps that can be bought with $20? Converting 45 cents into dollars, that's 0.45. So what we want to know is how many whole number of times 0.45 goes into 20. And we do that by division. So 20 divided by 0.45 equals 44.444 and so on. And we're only interested in the whole number component of the answer, since what's after the decimal point refers to part of a 45-cent stamp, which is impossible. We can only buy a whole number of 45-cent stamps in this particular context. So in this case, 44 45-cent stamps may be bought with $20. Question 27. What fraction, when added to 1 over 4, gives 1 over 3? We can form an equation 1 over 4 plus x is equal to 1 over 3, where x represents the fraction that when added to 1 over 4, we get 1 over 3. So x represents the difference between 1 over 3 and 1 over 4. So rearranging the equation to make x the subject, we get x is equal to 1 over 3 minus 1 over 4, which equals 1 over 12. Question 28. The clock shows the time at which a train left Sydney. It arrived in Gosford after 1 hour and 35 minutes. At what time did it arrive? The time on the analog clock is 2:50. Now we don't know if it's AM or PM. I'm just going to assume it's in the afternoon, so I'm going to leave it as 2:50 PM. And the train arrives in Gosford after 1 hour and 35 minutes. So adding 1 hour and 35 minutes to 250, now we can use the calculator using the degrees, minutes, seconds button, or we can add it manually. We end up with 4 hours, 25 minutes, which is interpreted as 4:25 PM that the train arrives in Gosford. Question 29. The cost of framing a photograph is found using the formula C equals L plus B in brackets times 0.55, where L is the length in centimeters, B is the breadth in centimeters, and C is the cost in dollars. Find the cost of framing a photograph whose dimensions are 8 centimeters by 6 centimeters. The breadth refers to the width of the rectangle. Now the dimensions of the rectangle are 8 centimeters by 6 centimeters. So L is equal to 8 and B is equal to 6. So substituting these two values for L and B in the formula, we get the cost C is equal to 8 plus 6 in brackets times 0.55, which equals to $7.70. Question 30. The timeline shows the party in government in a country from 1938 to 1998. Which of the following is closest to the percentage of time the Regal Party has been in government from 1938 to 1998? The total time represented on the timeline is 60 years, so that's from 1938 to 1998. Now, the Regal Party was in power from 1948 to 1956, which is 8 years, 7 years between 1971 and 1978, and 3 years between 1995 and 1998. So 8 plus 7 plus 3 is equal to 18 years in power over a total of 60 years. So 18 over 60, converting that into a percentage by multiplying it by 100 equals 30%. Therefore, the correct answer is option B. Question 31. In a raffle, 75 pink tickets and 25 blue tickets were sold. If 8 tickets are drawn at random, what is the most likely number of each colour? There are 100 tickets in total, of which 75 are pink and 25 are blue. Let's focus on the pink tickets. That means there are 75 pink tickets that were sold. So if 8 tickets are drawn at random, the most likely number of pink tickets that are going to be drawn is 75 times 8, which equals 6 pink tickets and 2 blue tickets. Therefore, the correct answer is option C. Question 32. Louis moves 4 units in a horizontal direction from point G. He then moves 3 units in a vertical direction to point H. Give one possible set of coordinates for H. Starting from point G, we could move to the right-hand side 4 units or to the left-hand side 4 units, and we end up at this point here or this point here. Then we could move vertically up or down 3 units, so we could land in any of these 4 points. This one, this one, this one, and this one here. And the 4 coordinates are 3, 5, or negative 5, 5, or negative 5, 1, or 3, negative 1. Just remember, it's x coordinate first, then the y coordinate when quoting coordinates. Question 33. The graph shows the marks scored by a group of students in an English test and a mathematics test. Which student was better at mathematics than Jan, but worse at English than Rob? A student who's better at mathematics than Jan will lie to the right of the point that represents Jan. So it could be either Bon or Con. Now, a student that is worse at English than Rob will be a point that lies underneath the point that represents Rob. And in which case, out of Bon and Con, the only point that satisfies those two conditions is Con. Therefore, the correct answer is option C. Question 34. Lynn's normal rate of pay is $6.80 per hour. On Sundays, she is paid a special rate, which is 1.5 times her normal rate. Each Sunday, she works from 7 a.m. to 2 p.m. How much does she earn each Sunday? The number of hours that Lynn works on a Sunday from 7 a.m. to 2 p.m. is 7 hours. Now, she earns a normal rate of pay of $6.80 per hour, but on Sunday, she earns a special rate which is 1.5 times her normal rate. So to find the total amount that she earns working each Sunday, we take the hours worked times the normal rate of pay, so that's $6.80 per hour, times the special rate of 1.5, and we get $71.40. Therefore, the correct answer is option D. Question 35. On 15 November, the ratio of people using the JetCat to people using the ferry was 2 to 5. If 8,000 people used the ferry, how many people used the JetCat on that day? We take the 8,000 divided by the term in the ratio that represents ferry, which is 5. That gives us the value of 1 part. So 8,000 divided by 5, and then multiplying that by 2 to give us the number of people that are represented by the 2 in the ratio, which corresponds to the JetCat, and we get 3,200. Therefore, 3,200 people used the JetCat on that day. Now note that the ratio 3,200 to 8,000, so that's the number of people that used the JetCat to the number of people that used the ferry simplifies to 2 to 5, which is equivalent to the original ratio. And that's one way to check that the answer is correct. Question 36. A barrel contains 15 marbles which are coloured red, white or blue. If you draw one marble at random, then you are most likely to draw a red, you are twice as likely to draw a white than a blue. What could the contents of the barrel be? Given the two conditions, there are two possible answers. Either 1 blue, 2 white, 12 red, or 2 blue, 4 white, 9 red. Make sure that the total number of marbles adds up to 15. 1 plus 2 plus 12 is 15. 2 plus 4 plus 9 is 15. Also, make sure that the number of red marbles is higher than the number of white marbles or blue marbles, and also check that the number of white marbles is double the number of blue marbles. If we were to extend the pattern to 3 blue, 6 white, 6 red, the second condition is satisfied, but the first condition is not, since we need more red marbles than white or blue marbles. Question 37. Find the value of x. Angles in a revolution add up to 360 degrees. And this symbol here, this square, indicates 90 degrees, or a right angle. So adding up the four angles, we have 120 plus 90 plus 2x, since we have two of them, equals 360. Now 120 plus 90 is equal to 210. So 210 plus 2x is equal to 360. Subtracting 210 from 360, we get 2x is equal to 360 minus 210, which equals 150. So if two angles, or equal size angles, are equal to 150, dividing 150 by 2 gives us the size of one of these angles marked with an x. Therefore, x is equal to 75 degrees. You can check your answer by adding up these four angles and checking to see that it equals 360 degrees. Question 38. The diagram shows 4 halls at a showground. The diameter of the circular hall is 76 meters. The 3 rectangular halls are equal in size and their total length is 195 meters. Calculate the area of the showbag hall in square meters. The width of the showbag hall can be found by dividing 195 by 3, since these 3 halls are equal in width. So the width is 65 meters. Now, to find the length of the hall, we consider the diameter of the circular hall. Now, a diameter drawn in any direction, as long as it passes through the center, which is what makes it a diameter, is always going to be 76 meters. So if we draw a diameter from here parallel to the length of the showbag hall, so from here all the way to here, that's also going to be 76 meters. So the area of the showbag hall is found by multiplying the length by the width. So 76 times 65 is equal to 4,940 square meters. Therefore, the correct answer is option B. Question 39. Lily left work at 5 p.m. and arrived home at 7 p.m. Which of the following do we need to know to calculate the average speed for her journey? The average speed is found by dividing the distance by the time taken to cover that distance. Now, we're told that Lily left work at 5 p.m. and arrived home at 7 p.m. So we know the travel time is 2 hours. So in order to calculate the speed, we need the distance between work and home. Therefore, the correct answer is option C. Question 40. Which statement is true? In an isosceles triangle, drawing a line that is perpendicular to the base through to the apex divides the isosceles triangle into two congruent or equal right-angled triangles. That means that the base of the isosceles triangle is divided perfectly in half. So in other words, 6 and 6. Let's consider this right-angled triangle here. And because it's a right-angled triangle and we have two known short sides, by Pythagoras' theorem, the hypotenuse x, or x squared, is equal to the sum of the squares of the two shorter sides. In other words, x squared is equal to 5 squared plus 6 squared. Therefore, the correct answer is option A. Question 41. In my wallet, I have $10 notes and $2 coins only. I can afford to buy 5 movies at $4.95 each, but I cannot afford to buy 6 songs at $4.65 each. How much money do I have? Let's consider the movies. Now we can afford to buy 5 movies at $4.95 per movie. So that's $24.75. So there's enough money in the wallet for this purchase, but there's not enough money in the wallet for this purchase here. 6 songs at $4.65 per song, which is $27.90. So if we have 2 $10 notes in the wallet, so that's $20, and we can afford this purchase here, counting up in twos. So if we have one $2 coin, that's $22. Add another $2 coin, that's $24. Add another $2 coin, that's $26. So we can afford this purchase here with 2 $10 notes and 3 $2 coins. Therefore, the correct answer is $26 in the wallet. Question 42. The figure shows an open tray in the shape of a triangular prism. Which diagram is the plan view? View from the top. Looking at the top view, we're only going to see the base of the tray since the sides are vertical. So they'll appear as lines when looking at it from the top. Therefore, the correct answer is option D. Question 43. The lines represent city streets. I can drive only in the direction of the arrows. In how many different ways can I drive from A to B? One way to tackle this question is to consider the symmetry of the paths. So we want to go from A to B, and we can only follow the direction of the arrows. So looking at a path from A in this direction, we can go this way. So that's highlighted in yellow. So that's one possibility. We could follow the path in green. That's another possibility. Or we can follow the path in red. So that's the third possibility. And because of the symmetry of this shape, and in particular the symmetry of the paths that are indicated, all we need to do is double the number that we just found. We could repeat the exercise this way. So there's one path from A to B here. There's a path this way. And there's also a path this way. And so that gives us 6 different ways in total. Question 44. If Sally works 8 hours overtime, she is allowed a day's leave. She works Monday to Friday. She earned a day's leave after working overtime each day for 4 weeks. On average, how many extra minutes did she work each day to earn the day's leave? The question is asking for how many extra minutes did she work each day to earn the day's leave. But what we do know is that she works Monday to Friday and she earns a day's leave after working for 4 weeks. So 5 days per week over 4 weeks is 20 days worked in that 4-week period. And she earns a day's leave after those 20 days. Now she works 8 hours overtime in that 20-day period. So we need to convert 8 hours into minutes. So 8 hours of overtime over 20 days, multiplying this value here by 60 gives us 480 minutes of overtime over 20 days. So to work out the amount of overtime worked per day, we divide 480 by 20, and that gives us 24 minutes of overtime per day. Question 45. Find the weekly tax installment for a visitor who earns $600 per week. The first thing we need to work out is which row of the tax table to reference. Now, the visitor earns $600 per week, which means we need to reference the second row of the tax table. Now, the second column gives us the instructions on how to work out the amount of tax that needs to be paid, which is $115.13 plus 34 cents for each dollar of earnings over 397. So working backwards, the earnings over $397 is worked out by 600 minus 397, which equals $203. So to find the tax paid, we just follow the rule, $115.13 plus 34%. That's what 34 cents for each dollar means. 34% times the earnings over $397. So times 203. And that equals $184.15. Question 46. A school has 120 mathematics prize winners. The column graph shows the number of mathematics prize winners in each school year. The sector graph of this same information is being drawn. What will be the size of the sector angle in degrees for the Year 9 sector? From the column graph, 25 Year 9 students won a mathematics prize out of 120. So the fraction of the school that are Year 9 students that won a prize is 25 over 120. Now there are 360 degrees in a full circle. So to find the size of the sector angle in the sector graph, we take the fraction that we just found, 25 over 120, we multiply that by 360 degrees, and that gives us 75 degrees. Therefore, the size of the sector angle in degrees is 75 degrees. Question 47. Peter has 100 matches which he is using to make this pattern. He wants to continue the line of hexagons, making as many as possible. How many hexagons will there be in the complete pattern, and how many matches will be left over? The first thing I'm going to do is to come up with a rule or an equation that relates the number of matches with the number of hexagons based on this pattern. So drawing up a table of values, H represents the number of hexagons and M represents the number of matches that are needed to make those hexagons. For one hexagon, we need 6 matches. For 2 hexagons, we need 11 matches. And for 3 hexagons, we need 16 matches. So for every increase in the number of hexagons, we need another 5 matches. So part of the rule is M is equal to 5H. But when we apply the rule, we note that the number of matches that are actually needed is 1 extra. So 5 times 1 is 5, but we actually need 6 matches, so we need to add 1. 5 times 2 is 10, but we need 11 matches. We need to add 1. 5 times 3 is 15. Adding 1, we get 16. So the rule is the number of matches is equal to 5 times the number of hexagons plus 1. Now Peter has 100 matches. So I'm going to solve the equation. 100 is equal to 5H plus 1. And that should give us the number of hexagons that can be made. Subtracting 1 from both sides of the equation, we get 99 is equal to 5 times H. And then dividing both sides by 5, we get H is equal to 19.8. So we can make 19 complete hexagons plus part of a 20th hexagon. It's not complete. Now, the matches that are needed for 19 hexagons is given by 19 times 5 plus 1, so using this rule, and we get 96 matches. And given that Peter has 100 matches, that means there are 4 matches or matchsticks that are left over. So therefore, 19 complete hexagons can be made from 100 matchsticks with 4 matchsticks left over. Question 48. Gina's marks on two mathematics tests are 74% and 68%. What percentage must she score on her next test for an average of 75% in the three tests? Now, Gina sits three tests and she wants the average to be 75% in all three tests. So using the formula for the average or the mean, we add up the scores, divided by the number of scores should give us 75. Now the third test, we don't know what that score is. That's what we're trying to find out. So 74 plus 68 plus x over 3 equals 75. Now 74 plus 68 is 142. So 142 plus x over 3 equals 75. Multiplying both sides of the equation by 3, we get 142 plus x is equal to 225. Subtracting 142 from both sides of the equation, we get x is equal to 225 minus 142, which equals 83. Therefore, Gina must score 83% in the third test. Question 49. All the measurements shown on the trapezium are in centimeters. What is its area in square centimeters? To find the area of a trapezium, we need the distance between the parallel sides and we need the length of the two parallel sides. These oblique sides are not necessary and are distractors in this question. So the formula to find the area of a trapezium is half times the distance between the parallel sides, or the perpendicular distance, multiplied by the sum of the parallel sides. So the area is equal to half times 8 times 7 plus 19 in brackets, which equals 104 square centimeters. Question 50. Which of the following can be correctly concluded from this graph? Let's consider the responses. Let's have a look at option A. The share price doubled on the first day. So starting at $8, on the first day it reached $10, and that's certainly not doubled. So option A is incorrect. Let's consider option B. The shares had no value at the end of the second day. Notice that the graph does not start from 0. It starts from $6. At the end of the second day, the shares had a value of $6. So option B is incorrect. Let's consider option C. The final share price was greater than the original share price. Well, the original share price is $8 and the final share price is $8. So option C is incorrect. So by the process of deductive reasoning, the only option left must be correct, assuming that there's no errors in the question, of course. So let's consider option D, just to make sure. The shares halved their value on one of the days. And if we consider this day here, they're $12. And on the next day, they're $6. Option D is correct. Question 51. The cost, C, in dollars of an apartment on level L of a building in Sydney is given by C equals 1,200,000 plus 15,000 times L minus 33 in brackets. Find the cost of an apartment on level 42. Using the formula and substituting 42 for L, we get C equals 1,200,000 plus 15,000 times 42 minus 33 in brackets, which equals $1,335,000. Question 52. One marble is chosen at random from a bag of marbles. Which statement is true if the probability of this marble being red is 1? If the probability of choosing a marble that is red is 1, that means its probability is 100% or certain. Which means that All of the marbles must be red. Therefore, the correct answer is option A. Question 53. A piece of pipe measures 1.3 meters. A piece of wood measures 1,230 millimeters. Which is longer and by how many millimeters? To make a comparison of measurement, they need to be in the same units. So I'm going to convert meters into millimeters because the question is asking for the answer to be in millimeters. So this 1.3 meter piece of pipe, to convert that into millimeters, we multiply that by 1,000 and we get 1,300 millimeters. So comparing that to the piece of wood, clearly the piece of pipe is longer. And the difference between these two measurements gives us how much longer the piece of pipe is compared to the piece of wood. So 1,300 minus 1,230 is equal to 70. Therefore, the pipe is longer by 70 millimeters. Question 54. A grandstand is built with a slope of 46 degrees. The distance D on the scale drawing represents 50 meters. Find the height h to the nearest meter of the back of the grandstand. There are two ways we can answer this question. In the first way, we can use the scale drawing, measuring the hypotenuse and the vertical short side as accurately as possible with a ruler. I get 135 millimeters for D and 97 millimeters for H. Knowing that D is 50 meters in reality, we get H is equal to 97 over 135 multiplied by 50, which equals 35.925 and so on, which rounds to 36 meters, correct to the nearest meter. Or we can use trigonometry. Since we have this angle here, we have the hypotenuse, which is 50 meters in reality, and we want to find H. So this is the opposite side, this is the hypotenuse. So using SOHCAHTOA, we'll need the sine ratio. So sine 46 degrees is equal to the opposite side over the hypotenuse. So sine 46 is equal to h over 50. Multiplying both sides of the equation by 50 to isolate h, we get 50 times sine 46 degrees equals h, and evaluating 50 times sine 46 degrees, we get 35.966 and so on, which also rounds to 36 meters. So it correlates with our answer here. Therefore, h is equal to 36 meters, correct to the nearest meter. Question 55. The number of telephone calls made on Saturday by 25 students is shown in the dot plot. Another student makes 2 telephone calls on Saturday. Which of the mean, median, mode, or range will change if these calls are included in the diagram? I'm going to add the 2 data points to this dot plot, and they're represented by the 2 x's here. Now, firstly, the range does not change. The range is the difference between the highest score and the lowest score. So in this case, it stays as 6 minus 0, which is 6. So option D is incorrect. Also, the mode, which is the tallest row of dots, in this case is 1, also does not change. The mode stays as 1. So the mode also is incorrect. Let's consider the median. Now there's 25 students, so the median is going to be the 13th score. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the original median is 7. After we add our 2 data points, we now have 27 students, or 27 scores. The median will be the 14th score. So if this is the 13th score, the 14th score is this one. So the new median also has not changed. So option B is incorrect. Therefore, by the process of deductive reasoning, the only option left is option A. Therefore, the answer is option A. Question 56. The height of a door is 2,400 millimeters. Use the scale drawing to calculate the width of the door in millimeters. Using a ruler, I measured the height of the door on the scale drawing to be 132 millimeters, and you try and do this as accurately as possible, of course. Now, the width of the door on the scale drawing is 49 millimeters. What we want to find out is what would the width of the door be in reality, or the actual width. And we work that out by using ratios or fractions. So the width to the height, or the ratio of the width to the height, we could represent that as a fraction, 49 over 132 multiplied by the height of the door gives us the width of the door in reality. And that equals 890.90 and so on, which rounds to 891 millimeters, correct to the nearest millimeter. Question 57. A school needs to determine the number of languages spoken by family members living at their homes. The information in the table was available. One student from each family is to be interviewed. Use the information to determine the number of students who should be interviewed. Let's consider the four options. If we consider option D, 380, this is greater than the total number of students at the school, so it's clearly incorrect, which leaves us the three options remaining, 180, 190, or 200. Now, if we consider 200, this includes students with no siblings, but it also includes students that have siblings. So it's possible if we interview all 200 students, that students from the same family are going to get interviewed. But it's clear here that it says one student from each family is to be interviewed. So 200 is incorrect. Now, if we interview 180 students, it's possible that we interview only the students with no siblings, which means we exclude any student that has at least one sibling. So 180 is also incorrect. Therefore, the correct answer is option B. Question 58. The cost of 4 hamburgers and 2 drinks is $16. The cost of 3 hamburgers and 1 drink is $11.20. Find the cost of 1 hamburger. Let's consider these two statements. So statement 1, the cost of 4 hamburgers and 2 drinks is $16. Statement 2, the cost of 3 hamburgers and 1 drink is $11.20. So reduce the number of hamburgers by 1, reduce the number of drinks by 1. We can then work out the cost of 1 hamburger and 1 drink. So 4 minus 3 is 1, 2 minus 1 is 1, 16 minus 11.2 is 4.8 or $4.80. So we can deduce that 1 hamburger plus 1 drink costs $4.80. Now the question is asking for the cost of 1 hamburger. So I'm going to form another pair of equations here. We know that 3 hamburgers and 1 drink is $11.20. So this is from statement number 2 here. And we were able to work out that 1 hamburger and 1 drink is $4.80. Let's reduce the number of hamburgers by 1 and reduce the number of drinks by 1, which will reduce the cost by $4.80. So 2 hamburgers will cost $6.40. Dividing both of those values by 2 to get the cost of 1 hamburger is given by $6.40 divided by 2, which gives a price of $3.20 for 1 hamburger. Question 59. Use the following information to answer questions 59 and 60. 20 people were surveyed to find the time they waited for surgery at the local hospital. The results are shown in the table. Find the mean waiting time. To work out the mean, we need the sum of scores over the number of scores. Now, to get the number of scores, we add up the frequency column, which in this case represents the number of people. So 1 plus 5 plus 7 plus 4 plus 3 is equal to 20. Next, we need to find the sum of scores, and we can do that by creating another column called the FX column. And we calculate these values by multiplying the score, which in this case corresponds to the waiting time, multiplied by the frequency of that score, which is the number of people. So this value here is given by 1 times 1, which gives us 1. 2 times 5 gives us 10. 3 times 7 gives us 21. 4 times 4 equals 16. And 5 times 3 equals 15. So adding this column up gives us the sum of scores, which is 63. So the mean is found by dividing the sum of scores by the number of scores, which equals 63 divided by 20, which equals 3.15. Therefore, the mean, which is represented by the symbol x bar, is equal to 3.15. Question 60. One person was chosen at random from the survey. What is the probability that this person waited at least 4 months for surgery? The number of people that waited at least 4 months for surgery are found by counting the number of people in this row here and this row here. So the number of people that waited 4 months for surgery is 4, and the number of people that waited 5 months for surgery is 3. So at least 4 months includes this value here and this value here. So out of the 20 people that were surveyed, 7 out of 20 waited at least 4 months for surgery. So the probability is 7 over 20, which as a percentage is 35%. Therefore, the correct answer is option B. Question 61. ABCD is a rectangle with length 11 centimeters and width 8 centimeters. AE equals FC equals 5 centimeters. Find the perimeter in centimeters of the shaded part. The question is asking for the perimeter of this shape here, which is a trapezium. Now, AE is equal to FC, which equals to 5 centimeters, and that's given here. We're given that ABCD is a rectangle with length 11 centimeters and width 8 centimeters. So to find the perimeter of this shape, we need length AF. Let's consider this right angle triangle here. Now, side DF is 6 centimeters. Now we know that this is 5 centimeters here, which is the same here, 5 centimeters, and 5 plus 6 gives us a total of 11 centimeters, which is the length of the rectangle. So this is 6 centimeters, this is 8 centimeters. Using Pythagoras' theorem, AF is a hypotenuse, so x squared is equal to 8 squared plus 6 squared. And x squared is equal to 100 when we evaluate 8 squared plus 6 squared. Taking the square root of both sides, we get x is equal to 10 centimeters. So to get the perimeter, we've got 10 centimeters here, 5 centimeters here, 10 centimeters here, and 5 centimeters there. So the perimeter P is equal to 10 times 2 plus 5 times 2, which equals 30. Therefore, the perimeter is 30 centimeters. Question 62. A frame is to be built with 4 joins only as shown. The timber to be used is 10 centimeters wide and is sold in 2 meter and 3 meter lengths. What lengths of the timber would you order so that a minimum amount would be wasted? Let's consider the frame to be built. We have 2 1.8 meter lengths that are needed. We also have 2 1.1 meter lengths that are required. And we get that because it's 1.3 meters from here to here, and it's given that the timber to be used is 10 centimeters wide, which is 0.1 meters. So that's 0.1 meters here, 0.1 meters here, so that's 0.2, 1.3 meters from edge to edge minus 0.2 gives us 1.1. So 1.1 plus 1.8 is 2.9 meters, which is very close to 3 meters. So it stands to reason that 3 meter lengths are ideal. Let's consider the options. We have two 2-meter lengths and one 3-meter length, which means we're using 7 meters of timber. Now the amount of timber we actually need is twice this value, which is 5.8 meters. So that's a lot of wastage, especially compared to the other options, which we'll consider shortly. Now option B, 3 2-meter lengths, that's 6 meters of timber, seems ideal. However, the issue that we have is that the 2-meter length will have to be cut down to 1.1 meters, which gives us 0.9 meters left over, which cannot be used in the frame. So option B, interestingly enough, has a lot of wastage. So we can't consider option B either. Let's consider option C. Now it's 2.9 meters here, and another 2.9 meters from here and then here. So that's 5.8 meters altogether. One 3-meter length can be used to make half the frame with 0.1 meters wasted. So in total, 0.2 meters would be wasted if we went with option C. And option D, for 2-meter lengths, we're using 8 meters of timber, clearly a lot of wastage there. So the correct answer is option C. Question 63. 4 solids are sitting on a horizontal table. A horizontal cut, AB, is made through each solid as shown. In how many of the solids will the cross-section made by the cut be a rectangle? In all 4 of these solids, the cross-section made by the cut will be a rectangle. Therefore, the correct answer is option D. Question 64. Given the formula P equals 2L plus 2B, find L when P equals 100 and B equals 8. Substituting 100 for P here and 8 for B here, we can form the equation 100 equals 2 times L plus 2 times 8. Now 2 times 8 is 16. So the equation becomes 100 equals 2 times L plus 16. Subtracting 16 from both sides of the equation, or we can think of it as moving this positive 16 over to the other side, it becomes negative 16. We have 100 minus 16 is equal to 2 times L, and 100 minus 16 is 84. So 84 equals 2 times L. Dividing 84 by 2 to isolate the L, we have 84 divided by 2 equals L, therefore L is equal to 42. Question 65. 4 friends tried to select the winning teams of 3 games. Their selections are shown in the table. No one selected 3 winners. No one selected 3 losers. What could the 3 winning teams have been? Let's consider the options. Option A, buffaloes, crocodiles, emus. Now these were the 3 teams that Sam chose. But it's given here that no one selected 3 winners. So these cannot be 3 winning teams. So option A is incorrect. Option B, wombats, crocodiles, foxes. These were the 3 teams that Pam chose. And again, for this reason here, no one selected 3 winners. These 3 teams cannot be 3 winning teams. So option B is incorrect. Looking at option C, we got buffaloes, dingoes, foxes. Now, none of these appear here. In other words, Cam did not select any of these. But for the second reason, no one selected 3 losers. So one of these has to be a winner. So option C is incorrect, which leaves us option D, which means option D must be the one correct. But let's consider where they appear. So wombats, dingoes, emus, they will appear under all these names. So Cam, we have wombats and emus, but crocodiles as a losing team. Looking at Pam here, we've got wombats only. Looking at Sam, we've got emus as a winning team or a potential winning team. And Tam, we've got wombats and dingoes. So the correct answer is option D. Question 66. 6 planes leave an airport at equal intervals. The first plane leaves at 9 a.m. and the last plane leaves at 10 a.m. At what time does the fourth plane leave? We can represent this situation using a number line. So the numbers on the top of the number line represent the planes. So we have plane 1, plane 2, plane 3, plane 4, plane 5, and plane 6. And the numbers at the bottom represent the departure times. So the first plane leaves at 9 a.m. The last plane leaves at 10 a.m. And there are 5 intervals in between. So the gap or the size of each interval is found by dividing 60 minutes by 5, and that equals 12 minutes. So the planes take off 12 minutes apart from each other. So if the first plane takes off at 9 a.m., the second plane takes off at 9:12 a.m., the third plane takes off at 9:24 a.m., the fourth plane takes off at 9:36 a.m., and so on. Therefore, the fourth plane leaves at 9:36 a.m. Question 67. Jessica wants to buy 20 square meters of tiles. Which of the following would be the cheapest? Let's consider the 4 options. So option A, tiles for $39 per square meter. Now Jessica wants 20 square meters, so the cost will be 39 times 20, which equals $780. Option B, tiles for a total price of $820, which is clearly more expensive than option A. So option B is incorrect. For option C, we need the area of one tile in square meters. Now 20 centimeters is 0.2 meters. We need to divide this by 100. So 0.2 times 0.2 is 0.04 square meters. To get the total number of tiles needed, we take 20 square meters divided by 0.04 and then multiply it by the cost per tile, which is $1.50, and we get $750. So far, this is the cheapest option. So option A is more expensive, so that's incorrect. Considering option D, using a similar working out, so 0.1 meters times 0.1 meters gives us an area of 0.01 square meters. 20 divided by 0.01 gives us the number of tiles that Jessica needs to buy. Multiply that by 0.40, which is equivalent of 40 cents but in dollars, and that equals $800. So option D is more expensive, which gives us option C as the correct answer. Question 68. The shaded design is made from 4 of the small triangles. What is the perimeter of the design? Analysing the shape, part of the perimeter is the hypotenuse of the 4 triangles. So we have C plus C plus C plus C, which gives us 4C. So that means option D is incorrect. We don't want 4C squared. In fact, we don't need to use Pythagoras' theorem in this particular question. Now, all the other options have 4C visible. So 4C here, here, and here. Now, the other part of the perimeter is this side here, which is side B minus side A. And that's where this B minus A comes from. And there's 4 of those. So we're going to add on 4B and subtract 4A. Another way we could write it is perimeter equals C plus B minus A in brackets, and there are 4 of those, so we multiply that by 4. Expanding the brackets, we get perimeter is equal to 4C plus 4B minus 4A, and that gives us option B as the correct expression. Question 69. Only 2 axes of symmetry are possible in which of the following? Note, there may be more than one correct answer. Looking at the 4 options, An ellipse has two axes of symmetry, so option A is correct. A circle has infinite axes of symmetry, so option B is incorrect. A kite only has one axis of symmetry, so option C is incorrect. And a rectangle has two axes of symmetry, so option D is also correct. So the correct answers are options A and D. Question 70. Which of the following nets, when folded, will form a solid? Note, there may be more than one correct answer. By inspection, option A and option B do not form solids. In fact, we're going to get overlapping sides if we were to try and fold it all up. However, option C and D will form a solid. Option C will form a tetrahedron or a triangle-based pyramid, and option D will form a cube. Question 71. For which of the following equations will the solution be x equals 10? Note, there may be more than one correct answer. Substituting 10 for x in option A, we get 10 minus 2 is equal to 8, and 3 times 8 is equal to 24. So this statement is true, therefore option A is correct. Let's consider option B. 10 minus 2 is 8, so we do what's in the brackets first, and 3 plus 8, it's all written here, 3 plus 8 is equal to 11, and this is also a true statement, so option B is correct. Let's consider option C. 10 minus 2 is 8, and 3 minus 8 is equal to negative 5. But we have positive 5 here. So this statement is incorrect, so option C is wrong. And considering option D, 3 plus 10 over 3, that's 13 over 3, which certainly is not 10. So this statement is incorrect, therefore option D is wrong. Question 72. Two parcels are weighed separately on a set of scales. What is the combined weight in grams of both parcels? Looking at the scales, and in particular the intervals here, we need to work out what the spacing of each interval represents. So this is 1 kilogram, this is 2 kilograms, 3 kilograms, and so on. So there's major intervals and there's minor intervals. So there's 1, 2, 3, 4 major intervals between 1 and 2. So this is 1 kilogram, this is 1.25 kilograms, this is 1.5, 1.75 kilograms. Now to work out the minor intervals or the subintervals. Between 1.5 and 1.75 or 1.25 and 1.5 kilograms, there are 5 subintervals. So I'm considering this section here. So to work out the spacing of each subinterval, we do 1.5 minus 1.25, and we divide that by 5 since there are 5 minor intervals, and that equals 0.05 kilograms. So as the pointer moves along to each subinterval, it's adding or it's indicating an extra 0.05 kilograms. So reading this weight here, starting off at 1.25 kilograms and adding 3 subintervals where each subinterval is 0.05 kilograms, we get 1.4 kilograms for this parcel. Similarly, for this parcel here, the pointer indicates 2.75 kilograms. So 1.4 plus 2.75 is equal to 4.15 kilograms, and there are 1,000 grams in a kilogram, so multiplying this number here by 1,000, we get 4,150 grams as the total mass of both parcels.